Today's puzzle is about moving numbers through a circular list. So my gut instinct was to prototype this in C. It sounds like a poster child for a doubly linked node. So here's our node type with a previous node pointer and a next node pointer, then the actual payload, and I needed an array of those. And once I finished the prototype, I thought to myself, wait a minute, if these pointer all point into the same array, then I may just as well just store indices. So in Clojure, I use an array for all the pref indices, an array for all the next indices, and then a vector for the payload. Okay, so how do I initialize the pref and next arrays? Here you can see it. So I want a sequence that maps 0 to 6, that's a wraparound, and then 1 to 0, 2 to 1, 3 to 2. So basically a simple decrement, but for the wraparound I use the mod here. And you may think, wait a minute, a negative number mod 7, isn't that still -1? Well, if I use the remainder function, then yes, that would be indeed a negative number. But the modulus function gives us the correct result, because this operator isn't actually called modulus. It seems many people get this wrong. This is the remainder operator. Okay, and if we look at the implementation, we first start out by computing the remainder, and then if the result would be negative, we simply shift it back into the positive area. Okay, and similar for the initial next, here's just the increment instead of the decrement. So here are the normal increments, and here's the wraparound from 6 to 0, the exact opposite of this guy. Okay, then I wrote a function that works for both parts by simply parameterizing the function with two numbers that will be 1 for part 1, a decryption key, and the number of rounds. For part 2, we have different numbers there. Okay, so first we pass our numbers. It's just a string containing numbers, nothing special. Then we count how many of them there are, and then we convert our initial prefs into an int array and the initial nexts into an int array because we want to mutate them. Then we loop once for part 1 or 10 times for part 2. And we want to move every number that is at index I in our vector. So how are we going to do that? First of all, we have to determine the neighbors. So here we determine the left neighbor and the right neighbor, and graphically it looks like this. And if we had implemented this with pointers, then here you would see the 4 pointers. So L points at I with the next, and I points at L with the pref, and similar here. Okay, but still conceptually useful, this diagram, I think. Okay, so this is the situation, I between L and R, and now we want to unlink I because we want to move it somewhere else. So in effect, what we want to do, the next of L should be R, and the previous of R should be L, and that's exactly what we do here. The next of L should be R, and the previous of R should be L. Okay, so then I is unlinked from the list. Then we have to find the new neighbors for the new position of I, so we start at the ones that we computed just yet. Then we compute how many steps do we have to move to the right. That's basically just the ith number in our vector, but for part 2 we have to multiply that with the decryption key, and the number can get very big, and it can be or can get negative. And so we also use the mod function here and compute mod dec of n. Why dec of n instead of just n? Because we unlinked I from the list, so the list is currently 1 element shorter. That's important to decrement it here. Okay, and then we want to repeat steps times. So if steps is still not 0, we recur. Here is graphically what we want to do. So the old R becomes the new L. The old R becomes the new L here in the code. And then we want to shift R1 to the right to its next neighbor. And that's exactly what we do here. Nexts of R will become the new R. And of course we decrement the steps, and sooner or later we will reach 0. Right, then we found the new position of I. I should go here between L and R, and for that we have to modify 4 pointers or 4 numbers, and that's exactly what we do here. Next of L should be I, that's this pointer. Next of I should be, or previous of I should be L, that's this pointer. Next of I is R, that's this pointer. And previous of R is I, that's this pointer. And then we have moved one number around. We do that n times for every number, and then 1 or 10 rounds. Okay, then what do we do after having moved everything around? we shall find the number at 1k, 2k, and 3k starting after the value 0. So first we have to find out where is the value 0 in our vector. And then we call the iterate function, which will repeatedly call this function on our initial index. And this just goes to the next index to the right. So we get a sequence of indices through our new list as it currently is. Okay, and then we map the this function over it as a first approximation for part 1. So we convert the indices to the actual numbers. And for part 2, we also have to multiply with the decryption key. Okay, and then we want to take every number where the index is a multiple of 1,000. So 0, 1k, 2k, 3k, 4k, 5k, and so on ad infinitum. We're not really interested in 0k, but only in 1k, 2k, and 3k. So we fetch those values via destructuring from this infinite lazy sequence. Okay, and then we just have to add them up, and that's everything.